Galvanometer. Galvanometer is a device which we use in the measuring instrument, because it is used as, it can be converted into voltmeter, it can be converted into ammeter. So ammeter is used to measure the current through the circuit. Ammeter and voltmeter is used to measure the voltage across any point in the circuit. A galvanometer is a very sensitive instrument. That is, when a small current is flowing, it will show deflection by showing that there is a presence of current in the circuit. So galvanometer arrangement, simplified arrangement. So in the books it is given how the coils are coming, how it is turning, but I made a simple arrangement. This is the galvanometer. It has got a pointer. That pointer moves over the scale. When no current is flowing, in the see here, when no current flows in the galvanometer, when no current flow in the galvanometer, it is what? It means here there is no current is flowing through this one. Whenever there is current flowing, the pointer will move from 0 to maximum. Okay, when no current flows in the galvanometer, it shows no deflection. It will not show any deflection. See, this is mean equilibrium position. When no current, I is equal to 0. Suppose when next, this is known as this position. When no current is this position is known as equilibrium position. Equilibrium position of galvanometer. Equilibrium position, it means when no current is flowing, this is known, this condition of the galvanometer is called equilibrium position of the galvanometer. When current flows, suppose when current is flowing here, this will show deflection. The galvanometer will show deflection, indicating that there is a current flowing through this circuit, that is through the galvanometer. So it will show when current flows, it shows deflection by means of this pointer. Pointer will move from 0 to the maximum. Now you see the galvanometer deflection. The galvanometer deflection is proportional to current flowing through it. Current flowing through it. It means whenever current is flowing, the deflection shown by the pointer on the scale is proportional to the current in the coil. So the galvanometer will having a coil, and when the current is flowing in the coil, it will show deflection. And the current is proportional to, and the current which is shown, current is proportional to potential difference. Which potential difference? Potential difference is whenever a current is galvanometer, we connect between 2 points. What is the potential difference between these 2 points? That is shown by the galvanometer. To say this, when current is flowing in the galvanometer, it shows deflection by means of the pointer, and the galvanometer deflection is proportional to the current in its coil, and the current is proportional to potential difference. So now full scale deflection. Full scale deflection means, see, the galvanometer is here and it should show up to here. That is called full scale. For full scale deflection, Ig is the current. See, if Ig is equal to full scale deflection in galvanometer. It means if I is less than Ig, that deflection will be, see, if I is less than Ig, it will show deflection, but it will not show full deflection. It will come according to the current, proportional to the current, it will show the deflection. The deflection will be less than the full scale deflection. So Ig is the full scale deflection current in the galvanometer, and the corresponding potential for full scale, the corresponding potential difference for full scale deflection is V. That is, V is equal to I, that is full scale current, into galvanometer resistance. V is equal to Ig into G, where V stands for the corresponding potential difference for the full scale deflection. So where G is, what is G? G is the galvanometer, where G is equal to galvanometer resistance. Because galvanometer resistance, why there is a resistance in the galvanometer? Galvanometer will be having a coil. When the current flowing through the coil, it deflects. Because of deflection, we get the pointer attached to is moving on the scale. Therefore, the coil will also have resistance. That resistance called galvanometer resistance. That is resistance in the, that is G is equal to resistance in the coil of galvanometer. So here afterwards we will be using only the circuit will be like this. The circuit will be, this is a galvanometer with a resistance. It is connected. It may be converted into voltmeter, or it may be converted into ammeter, that we are going to see later.